So
Okay.
I'm doing the special homework and I'm a little stuck on question two and question four specifically. Just on the algebra part, I'm on the induction step and I got to the by induction where you substitute
Mm-hmm.
for those parts, and I'm just a little confused on where I'm supposed to go to change the left hand side to the right hand side.
Okay. So let's look at number two first. This is special homework number 9.
Yes.
Okay, so number two, what is the statement in number two? Can you read it to me? What is P of N?
P of n is, hold on, sorry, let me switch bases. P of n is, where am I? The sum of I to n with the term 5i minus 4
So from I equals 1 to N,
1 to n, yes,
and what is the other side looking
equals
like?
n times 5n minus 3 over
N
2.
times the quantity,
The
5N minus
quantity
3.
5n minus 3, yes, over
Okay,
2.
so you're stuck in the algebra part in the induction step?
The n times 5n minus 3 is over 2.
Oh, it's over 2. Thank you.
Sorry.
But no, that's fine. That'll make a difference.
Okay.
So, we let K greater than or equal to 1 be an integer, right?
Yep.
So, uh, what did you assume?
Let's see. Assume that p of k is true.
All right. So what is P of K precisely? Because we need to write that down.
That the sum of I equals 1 to k with the term 5i minus 4 equals the quantity of k times 5k minus 3 over 2.
All right. So great. You've got your inductive hypothesis. Let's put a box around that just so we know what our proof money is.
Okay.
I mean, I'm assuming you had no problem with the basis step,
Yes, that was easy.
P of 1. Okay. So what do you wish to show?
That p of k plus 1 is true.
All right. Can you be more specific now?
So the sum of I equals 1 to k plus 1
Uh-huh.
with the term 5i minus 4
Uh-huh.
equals the quantity k plus 1 times 5 times k plus 1 minus 3 over 2.
All right. So if we work on, this side a little bit more, we can see, what is this, 5K plus 2 altogether?
Sorry, what'd you say?
When we think about what this right side really looks like in our wish, this factor, doesn't it reduce to 5K plus 2?
I did not think about that actually. I do not have that.
Like sometimes it's helpful to kind of take another step and see, what you're shooting for. Let's do that. Let's just go ahead and because it's kind of hard to see what this really looks like. But it looks like K plus 1, the quantity K plus 1 times what? 5K plus 5 minus 3 is a grand total of 5K plus 2. Do you agree?
Yes.
All right, so that might help us a little bit. So then what did you do? Hey, Kendall,
So I used substitution and then split the,
substitution. It's not time for
sorry,
substitution.
not substitution yet. You'd split it first. You split the left-hand side of p of k plus
Okay, so starting with the left-hand side of what?
1. The sum of I equals 1 to k plus 1.
So we're
Uh,
starting with the left-hand side of P of K plus 1.
yes.
So we've got the sum from I equals 1 to K plus 1 of the quantity 5I minus 4. So you split that off, and what did you get?
The sum of I equals 1 to k
Yep.
with the quantity 5i minus 4 plus the sum of I equals k plus 1 to k plus 1 with the quantity 5i minus 4.
Okay. That looks good to me. That looks right.
Okay.
And so you did this splitting off because you're gonna work on this. You're gonna make a substitution now into this, correct? Using your
Yes, this is
inductive
where you do
hypothesis.
the by induction.
And that is by induction. Let's make sure and say that. By induction. All right, so what is your substitution into that side? What does it look like?
So here I have k times 5k minus 3 over 2.
That's right, K, because that's the right-hand side. This is the left-hand side of P of K. You're substituting in the right-hand side of P of K because we have assumed that that is true. And then this is plus this sum, which we will evaluate in the next step.
So would it just be, when we evaluate it, would it just be 5 times k plus 1 minus 4?
Yep, so it's plus 5 times the quantity, K plus 1 minus 4,
Okay.
right? So we have to be sure and multiply the 5 across here. Now let's just compare. You said you're having a hard time getting to, to this or to this. It might be easier to shoot for this, and then we can easily change this into that in one step. So it looks like it's a single fraction, a single quotient with a 2 on the bottom.
So can I
Well,
multiply it by 2 over 2?
right, you multiply this term by 2 over 2 to get a common denominator. Very good. All right, we have room right here to do that. So this is all going to be over 2 now. All right, so the k times 5k minus 3 is already over 2. We can leave that like that. But we have to multiply this whole thing. And actually, what is this? We can go ahead and reduce this. This is 5k plus 5 minus 4. So what does that reduce to?
For the well, do you want me to multiply it the 2 times 5, or do you want me to?
No, no, we'll do that in the next step. The 2 and the 2 are
So
here.
5k plus 5 minus 4, so
Uh,
5k plus 1.
all right, so great. So we've got 5k plus 1 being multiplied by 2. Whole thing is over 2. Great. I think are you seeing now that you're going to be able to get to this?
Yes.
Because you know this is one of those where you're going to have to go ahead and distribute,
Okay.
right? I mean, the point is this. So this is number 2 continued. Sometimes we can just factor out, like, oh, wouldn't it be nice if we could factor out a k plus 1 from this term and this term, but there isn't a k plus 1 available, right?
Okay.
So we have to actually say, okay, this is 5k squared minus 3k, right? Plus
Hmm.
10k, what, plus 2?
Yes.
And now we're going to rearrange these. So we've got, or at least combine like terms. So we've got a grand total of what, plus 7k in the middle?
Plus 7k plus 2. Okay.
And then we actually can just use this as a guide. This is not that easy to factor, but it's not that bad. This is prime. So it's only factors for 5 and 1. We know that we have to have a 1 and a 2 because those are the things that would multiply together to make a 2 here. So the real question is, when we factor this numerator, I'm going to, I would normally put the bigger coefficient first, right? So I know it's going to be a 5k times a 1k to get 5k squared. The only question is when we get, it's all pluses, right? Because it's plus here and plus here,
Okay.
right? And it's all over 2. The only question is, does the 1 go here and the 2 go there, or does the 1 go here and the 2 go there? See what I mean?
Okay.
But you can always check your factorization by doing the distribution and see if you get this, right?
Oh, okay. All right.
See what I mean? Like like knowing that you need this can really help you if you have trouble factoring.
All right.
Like one of the factors is going to be k plus 1. That tells us right now this has got to be the 5k plus 2. And you can check it. It's 5k plus 2k for a grand total of 7k. So again, your wish is almost like a little cheater sheet. You're shooting for this, right? And
Yeah.
so, when we got to here and we realized, darn it, we can't factor out a k plus 1. We're going to have to go ahead and just crank this out. It's not that bad.
Okay. All right. That clears it a lot. Just really
Yep.
confused on that
Yep.
one.
And they're all different. I mean, I can't emphasize that enough. Every one of these problems is different. Every one of them is going to present a different and interesting algebra challenge. So your job is going to be to train yourself to keep looking at what you're shooting for. And again, we simplified, our wish from this to this, just to, because this would be hard to see how it connects to this, right? But when we see this, it's easier to see, oh, okay, but either way you slice it, there was already k plus one factored out. We knew we'd have to factor out a k plus one. It would just be a matter of time before you figured this out. It's just easier to see it here than like this. So it's perfectly legitimate, and then we can say, oh, well, now this is k plus one times 5 times the quantity k, uh, what was it? K plus 1 whole thing minus 3 over 2, which is the right-hand side. See what I mean?
Yes.
It really will help you if you look at your wish really carefully and sometimes even work on it a little bit inside your thinking notes to get a better idea of what you're really shooting for.
Okay.
All right, and so you're having a similar issue you said with number 4.
Yes.
What is the statement in number 4, please?
P of n, let's see. The product of I equals 2 to n.
Oh, this is a fun one.
Um,
1 minus 1 over I squared.
yep.
Oh yeah, I love this one. I think it's pretty.
And then equals n plus 1 over 2n.
Okay, so again, when you're doing the induction step, just keep your eye on the prize, right? So what should we let K be? Can you tell me the sentence to
K is
write
greater
here?
equal K is greater than or equal to 2, be an integer.
Perfect. And what's your induction hypothesis?
Let P of K be true, i.e. assume um, the sum of I equals 2 to K with the quantity 1 minus 1 half.
No, 1 over I squared.
Oh, 1 over I squared.
Yeah, 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 yeah. Okay, that might have been your
It's
problem
important
right
to think
there.
ahead. Yeah, let me put that down real quick.
Equals what, K plus
1
1
over
over 2K.
I.
Yeah, if you put a 1 half there, because you're looking at the 2, and that's a natural thing to do. I mean,
Okay.
these kinds of little algebra incidents are awfully natural, right? So just
All right.
all right.
Fix that.
So I bet you can, that's your assumption. Yay, proof money, all that good stuff. We're ready to play the P of K plus 1 game. And P of K plus 1, what this numerator becomes K plus 2, right? K plus 1 plus 1. But down here, we have to distribute this 2 across K plus 1, and it'll be 2K plus 2 downstairs, or 2
Okay.
times the quantity K plus 1.
Okay.
So, I bet you can do it now. It's really, it is just algebra there.
Okay. I think.
So Kendall's here. Hi, Joshua. Manaya's here. We're working on special homework number 9. And if you're a little bit late coming in, this will be posted. And we just worked through problem number 2. We just worked through the algebra we didn't write the basis step. Of course, you would start this with proof by induction, let P of n be this statement and all that good stuff. Be sure and write that. But we did work through already the entire inductive step for number 2. So you'll be able to find this in the notes, folks. And they will
I
go
think.
up right after our office hour. So does that take care of your questions, Nick?
Yep. I think that should be it for me.
Nice
Um,
job. Do you have any WebAssign questions?
I think I finished those up.
Good job. All right, who's got the next question? I see.
Have a good
Let's
one.
see. Let's do it in order. Yeah, Kendall, you were here first. What you got?
So I'm back to the WebAssign for me. For question
Sure.
5, I've been really struggling when we have to create the formula. Um, I could bet it's there the 4 plus 8 plus 12 plus 16 plus dot 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 plus
Okay,
160.
let me write that down. This is
Yeah,
WebAssign. 5253, obviously, right?
yeah.
So WebAssign 5.2, 5.3. And what problem number is it, please?
5.
All right, so tell me what it looks like on the left.
So it's 4 plus 8,
Ah, plus 16, or is it plus 12?
12, 16, and
Okay,
then our final is 160.
okay. And so we're supposed to use our formula for the sum to
Yeah.
figure this. Well, remember there was a hint that was given in class notes, and the hint says if you have k, some integer k times your sum from I equals 1 to n of I, then you simply multiply our formula, which is n times n plus 1 over 2 times k. It's over 1. The k is upstairs. So k, the point is if you have k plus 2k plus 3k plus dot 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 plus, some other, the nth multiple of k, that formula is k times n plus 1 over 2. We multiply our sum formula. See, this means you can pull a k out and you're left with 1 plus, 1 plus 2 plus dot 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 up to n. See what I mean?
Oh, okay.
Right. So you see you've got something
Mhm.
you can factor out there, don't you? Oops. Yeah, you've got a K you can factor out there. I think I just gave away the secret there. There's something you can pull out.
Okay, thank you.
You're very welcome. Joshua, you were the next in the room. Do you have a question? I can't hear you. You must be muted.
Oh, thank you.
There you are.
It was about question 4. It's just I wanted to fix the left-hand side.
Uh-huh.
It's regarding the product. It was like a product
It's
question.
this one.
The one with 1 minus
1
1
over I squared.
I
Uh-huh.
equals I over n. It's in the WebAssign.
It's
I don't know if it's the same thing.
I over what? Okay, so what number for WebAssign is it?
Number 4.
Oh, I'm sorry. So you're talking about number 4 from WebAssign.
Yeah, sorry.
All right, well, no, you're good. Let me pull that up because I do need to see that. Just give me a sec here. I'll pull up
All right.
WebAssign and I'll put it into the student view so that I can share that without giving away too much here. I'll share my screen here in a moment. Okay, let me share my screen. Okay, so we're looking at number 5.
Number 4.
Number 4. Okay.
Yeah.
Oh, well, we did this in class.
Yeah.
Yeah, this was done in class. This was done in class on Wednesday, Thursday. So it's
Okay.
day 19 class. We did this proof. So you'll
Okay.
find it in the class notes.
All right. And then other than that one, I think it was question 8 was my next one.
Okay, in WebAssign.
Yeah.
Okay. So number 4 was I'll just write this in the office hour notes, done in class.
Mhm.
Day 19, yeah. We did numerous proofs by induction on day 19.
And I got through most of it, but
Uh-huh. There's a little algebra in here.
yeah, that algebra right there, that continuous simplifying on the right-hand side, that's where I stopped at. I couldn't figure out
Okay, well, let's
how to
just
solve
take
it
a look at
properly.
what the right-hand side looks like right now. Okay, that's what the right-hand side looks like right now, okay?
Mhm.
Now, notice this times 7 to the k right here.
Mhm.
What is being multiplied times 7 to the k in this expression?
To 7?
7?
Because
Well, the point is we don't want a 7. Do you see a 7 here?
nope.
You see a 5. That should be a clue. So this, if we, get some scrap paper out and look at what this looks like, it's 5 times 7 to the k plus 2 times 7 to the k minus 2 times 2 to the k.
So you're taking out the 2's, and it's just going to be 5 times 7k times 2k.
Well, we have this. You have to use the inductive hypothesis. You're going to see a 7 to the k minus 2 to the k in there. Let's do it.
Okay.
All right. So all right. So here we go. Number 8. All right. So by the inductive hypothesis, and the definition of divisibility or divides. I wish they didn't say divisibility. I wish they would just say divides, but whatever. You all have all figured that out.
Mhm.
There exists an integer r such that, because the inductive hypothesis, of course, is that 7 to the k minus 2 to the k is divisible by 5. You understand that?
Mhm.
You know, this is the inductive hypothesis, right? But when we change it to an equation, it's that 7 to the k minus 2 to the k is a multiple of 5, namely the rth multiple, okay?
Mhm. Yeah.
All right, so we're going to have to use that. Then, here we go. We've got 7 to the k plus 1 minus 2 to the k plus 1, because we want to prove that this is divisible by 5, right?
Yeah. Mhm.
And we know somehow out of this, we have to extract a 7 to the k minus 2 to the k so that we can use this inductive hypothesis money, right?
Yeah.
So, we ask ourselves, what can we do? Well, they give you the big fat hint. They say, hey, you need to see a 7 to the k? Well, look at what you've got. You've got more than that. You've got k plus 1, 7. So extract 1. So that's how we start to see a 7 to the k. Same game with 2 to the k plus 1. That is 2 times 2 to the k. So we're closer now than we were here to seeing this. But we don't quite see it yet because this is too many 7 to the k's. We only need one of these, right?
Yeah.
And this is minus 2 copies of 2 to the k. We only need minus 1 copy of 2 to the k, right?
Mhm.
So we might think to ourselves, all right, there are lots of ways I can extract 1 copy of 7 to the k.
Could I possibly just factor it?
Well, you've got to just do something like this because you just want one of them.
Oh, okay.
Minus 2 to the k minus another 2 to the k. Now, why did I do this? Because I only want one of them, so there's going to be one left over somehow. Do you see it?
Oh, yeah, I see it.
All right, so now what do we got? All right, so we've got 6 times 7 to the k, because the 6 gets multiplied times 7 to the k, plus 1 copy of 7 to the k, right? That's why we did this. Minus 2 to the k, minus 2 to the k. Now I'm going to rearrange this. This is 7 to the k minus 2 to the k plus 6 times 7 to the k minus 2 to the k. I'm just putting these two together and these two together. Now we know we can put a 5r in for this because this is the 7 to the k minus 2 to the k, right? That gives us 1 copy of 5. But this isn't divisible by 5. So we do the same trick again. We know we've got 6 copies of 7 to the k here. If we just had 1 copy of 7 to the k minus 1 copy of 2 to the k, which we do have sitting here, we could substitute in 5r. So we repeat, and this one is going to yield the final happy result, because now when we distribute the 7 to the k across this parentheses, right?
Yeah.
We have 5r plus, hey, 5 times 7 to the k. That's great because it's got a 5 in it.
Yeah.
See, that wasn't so great. A 6, we didn't want a 6, right?
Yeah, we want a 5.
But now we've got plus 1 copy of 7 to the k minus this other loose copy of 2 to the k floating around, right?
Mhm.
And that, see, it's just the same way we grouped, this one and this one together here. Now we have this one and this one together here, and we can resubstitute in 5r again. And then, of course, in our proof, we're going to say, this substitution right here was by induction, because, that substitution is a by induction hypothesis substitution. And then this to here is another application of the same inductive hypothesis. Isn't that, it's like magic, isn't it?
Mhm.
And so what do we have? We've got 5 times, 7 to the k plus how many r's?
2 R's?
Yep. 1 here and 1 here. That's what's going to go in that parentheses. Doesn't matter what order you write this. You could write this as 5 times 2r plus 7 to the k. It should accept either one. Doesn't matter. So that one's an interesting problem because it's
Yeah, it
the
works.
only problem we've ever seen where we've used the inductive hypothesis twice.
Mhm. Yeah, it was stopping me on that because I can
Sure.
understand how to do everything else. Where like we have
No,
to say, or this one's true.
this is probably arguably the most difficult algebra you would see ever in this entire course right here. So
Would we have a question like this like on the test at all, or would it be?
why not?
You're right. But that's scary to me. But okay, I think I got it.
Well, let me ask you this. On test 2, did I ask you the worst, most horrible possible proof by cases that
Not
I
really.
could have? Or did I ask you a nice basic one just to see if you know what the heck proof by cases is?
Yeah, the latter. Yeah, I get
This
it.
is a tough little one. I throw this out there just for fun. So I
Mhm.
think that answers your question.
Yeah, it does. Thank you,
Okay.
though.
Okay. Manaya, how are you?
Good, how are you?
I'm good. Can I answer any questions for you?
No, I was just
You're
looking.
hanging?
Yeah.
Well, I'm glad you're in the room. Ritvik, it's your turn. Do you have a question?
Um, yes. I do need help with like couple of problems from the special homework 9.
Uh-huh. Which
And
which one?
uh
Which one first?
number 1 and number 2.
Well, number 2 was worked out pretty much before you got in the room. So
Okay, but it's the same for
yeah, number 2, this one.
yeah.
Okay, so it's worked out. We went through the algebra on pages 1 and 2, and these will be posted right afterwards, okay?
Okay, can we like work on number 3?
Uh-huh. Did you need help with number 1, or are you okay with number 1?
I kind of
That's the
needed
one. Need a little
help
help
with
with
like
that?
understanding number 1. So is it like a sequence?
Yeah. Can you read so there are two of them, and for both of them, we're supposed to evaluate, right? Using our formula. And I gave you some hints, right?
Mm-hmm.
Or did I give the hints again in the special homework? Or
I
did
don't
I?
think the only hint he gave was the formula,
Oh, okay.
but I don't know if there are any other hints.
Well, there are, but they are in the due later and in the class notes on both day 18 and day 19. I laid out some hints. Here's one of the hints.
Okay.
One of the hints, and we just talked about that earlier today, is that if we have a sum from I equals 1 to n of some, term, we don't know, whatever, a sub I.
Mm-hmm.
Here it was. Well, yeah, it works for any a sub I. You can split that sum as the sum from I equals 1 to j of a sub I plus, and then you pick up 1 after the j. In other words, pick up at j plus 1 and then go to n of a sub I. That's one of the hints. And let's just think about why that works, okay? I mean, what is this actually saying? Well, when you see it, it'll make perfect sense. It says, hey, if you've got a sum from I equals 1 to n of a term a sub I, what does that really look like? Well, the first term is a sub 1 plus, and the next term is a sub 2, right?
Mm-hmm.
Plus, I'm going to leave some room in the middle here, plus, and eventually you have a sub n. Well, what's happening in here? Well, there's some dots, but at some point, there's going to be an a sub j. And then the next term would be a sub j plus 1, which is just the next term because we're indexing by integers that increment by 1. So the
So,
point is, part of the hint is the range of j. This is 1 is less than or equal to j is less than or equal to n. So j is somewhere between 1 and n.
oh, okay.
Right. So you can see that this is just saying, hey, you can split that sum up between the a sub j and the a sub j plus 1. That's all this equal sign is saying. It's saying,
Okay.
hey, when you write it like this, you might have written it where you start at a sub 1, go dot, dot, dot up to a sub j, group those together, then pick up with a sub j plus 1, plus dot, 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 and just carry on until you get to the end, a sub n. See what I mean? So that's one hint.
So is it like ace of n meaning ace of j plus n?
No, this is j plus 1, and this would just be a sub n. The only
Okay.
reason, see, we don't know what j is, and we don't know what n is. We just know that n is bigger than j.
Okay.
So, I mean, j could be 3, and n could be, 15,
Mm-hmm.
and then j plus 1 would be 4.
Okay.
The point is you can split a sum up anywhere in here. You could have done it here between a sub 2 and a sub 3, or we could have done it here between n minus 1 and n as far as the indexing variables go. So that's one hint. And another hint is that if you find yourself looking at a multiple of the sum from I equals 1 to n of a sub n, right? That actually, that's just k a sub 1 plus k a sub 2 plus dot 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 plus k a sub n. But this has a special application when the term, oh, this should be an a sub I, my bad. When the term a sub I is just the indexing variable I, because when that's the case, when it's a special case, when we use the formula, then we're saying, hey, if it's the sum from I equals 1 to n of just plain old I, then what we have over here is k plus 2k plus 3k plus dot, dot, dot plus nk,
Mm-hmm.
which is another way of saying k get factored out of the sum from 1 to n.
Oh, so basically, okay, so 2 times 1k, 3k. So,
So we're just pulling a k out of each of these terms because that's what this does. It multiplies each term in the sum by k.
okay.
So there was like uh, here's an example. This showed up a few minutes ago from WebAssign. If we have 4 plus 8 plus 16, excuse me, plus 12 plus 16 plus keep on going to up to, I don't know,
Maybe infinity?
no, we wouldn't say 320. I don't remember what it was, but we'll just say some number that's bigger than 16. That's, what we can do is recognize that we're jumping by jumps of size 4 here between the terms. Do you see that?
Mhm.
Instead of jumping by jumps of size 1. We need to be able to jump by jumps of size 1 to use our formula, because that's what this formula is about. This formula is about 1 plus 2 plus 3 plus dot 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 plus n. So here, the key is to pull out a 4, and then suddenly you see 1 plus 2 plus 3 plus 4 up to, whatever this is. I guess it's 80. And then you
So,
can use the formula.
so technically there's like no, is there like a limit or is there no limit on the
It's
numbers?
it's unbounded, but in order to evaluate the sum, we need to pick a final value for n. Here n is 80.
But can n be any value?
Yeah, it can be as large as you like, but
Okay.
you can't put infinity here because then
Yeah,
the sum would be unbounded. I mean, we wouldn't be able to, I
it
mean,
has to be, it has to be any number that is, say, a multiple of k.
yes,
Okay.
if it's the factor out game.
Hmm.
So so let's just take a peek at number 1, part A from the
Okay.
special homework 9. Can you read me the sum that I gave you? Because I don't remember what it was.
Um, I think it is it part A?
Well, yeah, we should probably start with A, right?
Yeah.
I'll
All
grab
right.
this. I'll grab the special homework. I'll look at it.
Okay.
Is it hard for you to find it?
No, I
Okay.
already have it pulled up.
All right, so it's 8 plus 16 plus 24 plus 32. I gave you lots of terms so you could see what the pattern is.
I already know the pattern. It's basically like adding 8.
Yeah. So you're gonna, right? So K is 8,
Okay, let me write that down.
right? So you can just
Okay.
pull an 8 out,
Mm-hmm.
and now we've got 1 plus 2 plus 3 plus, 4 plus 5, dot, 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 plus what?
Let's say 300.
No, no, I gave you a number.
Hold on, let me go
This you should be able to divide by 8 in your head.
8008.
What's 8 divided by 8? 1.
Hold on 1 second.
Okay.
Oh yeah, so sorry.
No, you're
8
fine.
8008 divided by 8 is 1.
Okay. And then
So
the
it's
zero,
technically
zero.
1001.
Yep.
Okay, so
And then you would use your formula, but now n is 1001,
okay.
not 8008, but 1001.
Because 8008 divided by 8 is 1. So technically that's how you would do A and B, right?
Yeah, B's a little more interesting because I think I shifted B as well. So you have to use both hints for B.
Okay.
So in B, here, let me take a peek again. Let me pull this up where I can see it. Okay, yeah, yeah. So this one's kind of a combination. So it's 505 plus 510 plus 515 plus 520 plus keep on going up to 5555. 5,555. So do you see how it's a combination of both of those situations where, oh, yeah, you're going to pull out a common factor. What are we incrementing by? That'll be your common factor,
Okay.
right?
Probably 5 would be incrementing.
Yep. But look, it doesn't start at 1, does it?
Well, yeah, because it probably can start at any number, but
No, it has to start at 1/5 of 505. You have to use what's given.
oh, okay, so yeah, so 505 divided by 5, 101, and then 102, 103, 104, all the way to um 1111.
Yeah, I tried to make it so you could do it in your head, right?
Yeah.
So, but the thing is, of course, now we aren't starting at 1 because the formula says if you're starting, at 1 and then it's plus 2, plus 3, plus dot, 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 plus n, if you have that, we know that the formula is n times n plus 1 over 2. That is the formula that we have, right? But
Okay.
this situation isn't starting at 1. It's one of these shifty situations. So
Okay.
we have to use hint 1 that says, okay, it's okay to shift because if we look at this hint 1, we can subtract this sum from both sides. And then this sum will start in a shifted way down at j plus 1. So if we subtract from both sides of the equation, this is equation 1, right? I'll show you what it looks like. Now use hint 1 after subtracting the sum from I equals 1 to j of I from both sides. Actually, it was a sub I in the hint. I tried to give you the general. All right, so what does that mean? That means we would have the sum from I equals 1 to n of a sub I minus the sum from I equals 1 to j of a sub I is the sum that starts way down at j plus 1 to n of a sub I. So this appeared in class notes as a hint for the due later that was then the due now on day 19. So on day 18, was it day 18 or day 17? Anyway, this appears in class notes as a hint for a due later.
Okay.
But all we've done is we've just taken this formula that says you can split a sum up anywhere you want. You can split it between j and j plus 1 into 2 sums, here plus here.
Hmm.
But we can take this part and subtract it from both sides. You see, I'm just taking this over to the other side as a minus. And that leaves the sum that's shifted and starting at j plus 1, going up to n alone on this side. So here, when we look at what we've got, this is shifted. This is our j plus 1. This is our n. See, this is our a. This is actually j plus 1. This is because the indexing number is the term. So this is our j plus 1. This is our j plus 2. And this is our n up here. Does that make sense?
Yeah.
But the point is we've got a formula that we can apply. This is too close. I don't like it so close. I want to give myself some more room here so you can see the N. But the term A sub I, of course, is just I because this formula is for is the sum looks like the sum from I equals 1 to N of I. I is A
Okay.
sub I. This is the only time when the term A sub I is actually just the indexing number I. It never happens for any other
Okay.
formula.
All right. Thank you.
Does that help? Can you deal with this now?
Like, yeah.
Good. And don't forget your 5. So this is supplemented. It's like two things at once. So the point is 5 times the sum from I equals 1 to 1001 of I minus the sum from I equals 1 to 100 of I is going to equal 5
So,
times the sum from I equals 101 to 1111. Oh, this should be 1111. Right, because our N is 1111, isn't it?
okay.
So don't forget to multiply by 5 when you find this and you find this and you subtract them, then you have to multiply it times 5.
Okay.
Because what we have is 5 times the sum from I equals 101 to 1111, right? That's what this sum is. This is actually the sum 5, excuse me, times the sum from I equals 101 to 1111 of I. That's what this sum is.
Mm-hmm.
It's this. So
Okay.
just don't forget to multiply by 5.
All right.
Cool.
Thank you.
Oh, you're very welcome. Now that was so you said number 3.
Yes.
So what is number 3? Is it an induction proof?
It's an induction proof, but I think you did like an induction proof earlier ago, right?
I did. We looked at 2 and we looked at 4.
Okay. All right. Let's look at 3, I guess.
So can you read it to me, or this is homework number 9? Yeah, these are
Yeah.
really challenging. So number 3, actually, I may have it close by here. Um, oh yeah, it's the sum from I equals 1 to N of 1 over I times the quantity I plus 1 is equal to N over N plus 1, right?
Yeah.
That's a fun one.
Looks fun, but looks challenging.
It's really not as bad as it looks. And Rithvik, have you watched the video for day 19 class?
Um,
It's a simple yes or no.
no.
Watch the video for day 19 class, please. Why don't you
Okay.
do that now? And if you need another office hour, um, I don't want to just work them all, but
Okay.
you're coming in blind without having watched the video.
I'll probably come on Tuesday.
All right.
All right. Thank you.
Please watch the class video. That's why I hate to cancel class, because students, feel like, oh, I'll do it later, but you,
I also had that feeling because I have like other assignments to complete, so that kind of
I know, and you were so happy probably to have the time, I get it. I get it. And then the
Yeah.
weekend gets busy, but you got to watch the video. You've got to.
All right. I definitely will.
All right. See, day 19 class lecture.
All right.
All right.
Thank you.
You're welcome. Manaya, do you have any questions now that you've seen us go through some stuff?
Oh, sorry. No.
You okay?
Yeah, I don't know. I just have a little cough. But I just pretty much wanted to see everything. But have a good rest of your night.
Thank you.